Hi there, in my last video I was looking at the way that 20 LEDs could be controlled by 5 lines from a microcontroller. Doing this so that I could use these displays from discarded vapes in some of my projects. The idea is that we've connected 8, 9, 10, 11, 12 pins from the Arduino to the display. Here in this case I've used resistors. I'm not too sure if they're necessary or not. Some of the displays then, the older displays, have the connections along the bottom, and so we've got 8, 9, 10, 11 and 12 across the bottom on this display, but some of the older, the more modern displays then have the connections along the edge. So I've connected 8, 9, 10, 11 and 12 along the edges on this one. I happen to be using the older display just because it's easier to set up. So how's it working? Well, if we look at this particular display here, or even this one's better, it looks like all these segments are on at once. In fact, they're not. They're only on for a very short period of time, but because of persistence of vision, it appears like they're on all the time. I can actually go from, where are we going from? 199 down to 0 is the sort of maximum range I can get on this display. Could be used for a large range of things, counting and things like that, where we need a small display and don't want to go to the inconvenience of, say, a LCD display. How's it working then? Well, what it does, it uses a library from a website called GitHub, and the library is matrix-charlieplexing.h. This has to be put into our computer that we're programming our Arduino with, and then once it's in there we can use where are we? Got it here somewhere, a little crude program. So we've got this library, this library in our library, and there is an example, so we can load this little bit using the example into our computer, and that then just basically, it says we've got to include that library. We're going to use that namespace. We're going to set up an array of 8, 9, 10, 11 and 12, which is the pins that we're going to use, and then we need to set up MCH, which includes this array, and the 5, which is the number of pins, and then we're going to Charlieplex CA, which is common anode, which is what I'm using. I've taken out anything that's to do with coordinates, so I'm just using the numbers of the displays. So here we've got the numbers, so that will be 1, but its coordinates will be 0, 1. Well, I'm ignoring those and just using the numbers because I think that's easier. So if we go through this lot, then we find down at the bottom this LED stays on for about 3 seconds. So all we need to do to light any individual LED is to MCH, turn on the LED number, and here I've just delayed for 3 seconds so that we can see that that's how that works. That's not too difficult. What becomes more difficult is if we want to use the 7-segment display. The display itself then has the hundreds, which we just light up 14 and 15 if we want the hundreds. If we don't bother lighting them. And then we have the 2 7-segment displays. These then can be labelled A, B, C, D, E, F and G, the individual segments on both of these displays. So if we want to light something up, let's say we want to light the number 0, we would turn on all the segments except the 0. G at this end. So that would give us the 0. The 1 then we just turn on C and B, and that would give us a 1. For 2 then we do these, and we can build up this binary table which shows us which segments we're going to have to light for each individual number. That's a bit confusing, and I'd rather turn it to decimal. So to turn it to decimal, then this column's 1, this column 2, 4, 8, 16, 32 and 64. So for the 0 then I'd have to add all these numbers together to give me 126, which is my decimal mask for 0. If I wanted just a 1, then I'd turn on 32 and 16, which gives me a decimal number of 48. So then what I'm going to do is to go through and test each of these on this mask when it comes to the program, and if there's something there then I will light it. If there isn't, I won't. So that are the decimal numbers. I'm going to change those into mask numbers, or into an array, put those into an array with 10 segments in it for each of the 10 digits. So we get these numbers put straight into the array: 126, 48, 109, etc. So those are the numbers in that array. But the mask on its own isn't much use. We've got to change the mask then back into the segment units for the units and for the tens. So the segments units for A then, for the units would be 5, for B 1, C 9, and the tens segments for A will be 10. For A is 10, B 6 and C 11. So I've put those in there as well, and then I've turned those into an array, or 2 arrays. So we've got these units segments is this array here. I've put it the opposite way around because I'm going to start reading from this end and go that way. So those are the segments that I need to light for the units, and these are the segments that I need to light for the tens. Or at least if I lit them all, it would give me a number 8 if we lit them all, but we've got to leave some off. So now we've got our 2 arrays. Where do we go to for there? Well, now we need to go to our program. In our program, of course, we've still got the original bit about from matrix Charlieplexed.h. we got that, this and this, like we did before. Now I've put in a universal variable called val, and then I've put in my 3 arrays with the numbers in as we've done. On setup then I've just put in serial begin so that I can use the serial monitor if necessary, but that of course messes with the displays, and the displays don't work as we'd expect because of the time taken to go to the display display monitor. Okay then, so in the loop what I'm going to do is I'm going to analog read A0. I've just used A0, could have used A1, 2, 3 or 4, but I just happen to use A0, and I'm going to put the analog value from A0 into a sensor value, a variable I've called sensor value. Sensor value though could be 0 to 1023, and I only want 0 to 199. So what I'm going to do is to map, use the command map, so that val will only be 0 to 199. Then go off to my display. When I get to display, I want to break up the number val into hundreds, tens and units. To get the hundreds, I just divide val by 100. If it were 26, for example, there'd be no hundreds, so hundreds would be 0. If it were 126, hundreds would be 1, and therefore it would display the 1 later on. I need to do the same for units, so what I do is divide val, let's say 26 again, by 10, but in this particular case I'm just getting the remainder, and the remainder in this case will be 6, and then I can get the value for the tens, which would work out at 2. So I have 2 tens and 6 units. I need then to look at which mask I'm going to use for each of these. So the masks for the units would be mask numbers 6. So I come up here across to the 6, which will be 95. So I've got a mask unit of 95. And I then want the mask for the tens. So if that was 2, for example, I would come across and get 0, 1, 2, 109 as the mask unit for the tens. I then want this to operate for, say, 1/10 of a second, which is what this little routine here does. And then I'm going to go through each of my mask units and test each bit in turn. To do that, then we set off with k equal 0. I then recheck the bit in mask unit. If it's set, then I turn on the unit segment k. So I'm reading across here and lighting that particular segment. I then do the same for the tens. Bit read, we've got the mask for the tens now, and we've got k still 0. So we're reading the first bit of that. If that's set, then we turn on the k segment. If it's not, we don't. We then check the hundreds. If the hundreds are 1, then we're going to turn on the hundreds. If it's not, we're going to ignore it. We then go around again to our 4. So our 4 was 0 to start with. So now it's going to be 0 plus 1. So we do the same tests again with k as 1. Check if that bit's set. If it is, turn on the segment and keep going round and round until k equals 6. And then we will get k back equal to 0 again, going round and round for our 1/10 of a second. So after our 1/10 of a second is up, then we end this and go back again to our loop to get our next value for val, and then go and display that going round and round. So that then is how I've gone through the program. It's probably not very good. It probably could be done a lot better, but I haven't found anything on the internet that would tell me how to do it any other way. So hopefully this then will help somebody. And so it's bye now. Bye.